या हम लोग को लोग पूरा करते हैं उसने कार में कॉल किया था सुना था on behalf of Science Engineering College, Mumbai, welcomes you all in day in session 2 of literature program on developing secure IoT applications funded by AICTE organized by IT. We are glad to introduce total now we have 5 at Thermal Sahani Engineering College. He has completed PhD in cloud computing and big data analytics from Mumbai University. He has written 10 books with reputed publications. He published various research papers in reputed national, international journals and conferences. He has conducted research workshops on different topics in various colleges. He has overall 12 years of experience. Before I hand over the session to her, few announcements for participants. If you have any queries, please write in Q&A box. And attendance some feedback link will be provided in the chat box. May I now request Dr. Bhushan to start the session. Over to you, sir.
Yes, ma'am. Am I audible?
Yes, sir, you are audible.
Thank you very much, ma'am, for inviting me as a speaker. Faculty development program on IoT. So today I'm going to take the session on the IoT and the cloud security, right? So as you know, the cloud computing is basically as an integral part of all the emerging, right? So I want to give you a glimpse about the cloud computing initially, and then later on we'll show you one or two demos based on the Amazon Web Services, right? So I'm sharing my screen. Ma'am, just tell me whether. So I basically I have some internet issues, so that's why I'm not able to turn on my camera, right? So nowadays, as we know, most of the devices, most of the emerging technologies like big data analytics or the machine learning, deep learning, all those kinds of applications used to be run onto the cloud, and the cloud has a huge support for the IoT as well, right? So where you can have the your in-house IoT devices, IoT in-house IoT sensors, IoT controllers. So you could connect those controllers to the cloud platform like Amazon Web Services or the IBM Watson or the and Microsoft Azure. So once you connect that, you can manage the data flow between the different devices, right? So we basically choose a cloud at the backend to get the good bandwidth, to get the good processing power, right? But while implementing the cloud-based IoT, as we know, cloud basically runs on the public platform, and whichever services runs on the public platform are basically prone to the various vulnerabilities as well as the various security challenges, right? So we are going to we're going to see the such challenges, and I'm going to demonstrate how to do it in Amazon platform, right? So we'll go a little bit quicker. As you know, I'll just brush up the things. So as you know, Internet of Things, this which is nothing but the interconnection of people and the things, where you could have the multiple devices, right? And the devices are called as in things, and we connect those things to the through the internet or through the network to the applications. So it's an interconnection of people and things, and or we can say it's a things about things, right? So it's a rapidly evolving technology where billions of millions of connected devices are right now currently running over the internet or the intranet. Each device is called as a thing, right? What the entire world is where the IoT, different types of application using the IoT is like a home automation is there, where we could use the handheld devices to check the healthcare conditions, tracking and monitoring of healthcare devices, or we could use IoT in the entertainment industry, right? To use it for the surveillance kind of thing, or we could use the IoT in the security environment where we can do the anomaly detection or the any risk federation and all, or we can use it in we could see it is available for different utilities. Nowadays, it is being used in transport as well. So you could see, you can track the, you can basically use mobile devices to track the location of the things. So those things are nothing but the connected devices. So these things are basically available in a transport domain as well. So different applications are logistic management system, or the traffic monitoring, parking management, or the emergency services. The community services provided by the IoT are the factory-based production, retail outlet, environment, surveillance, business intelligence, smart metering. So all these things covers the aspect of the cloud computing. So Internet of Things, right? So this Internet of Things basically allows you to basically access this such kind of applications or the devices from anywhere at any time on any device or on anything also. Anything is nothing but the any device, right? So these are the aspect. These are the basic aspect of the Internet of Things. So when the Internet of Things was evolved, was started, the term Internet of Things was basically coined by the researcher Kevin Aston, right? Who basically worked on the different kinds of devices, and he found out in 1999 the Internet of Things. Then he has connected the controllers, the sensors, each and everything over the network and tried to access it over the network. So he coined it as an Internet of Things. He is the founder for the Internet of Things. However, the technology got the momentum in 2011. So in meanwhile, 12 years there was no gain for the Internet of Things. So after 2011, it got popular, and now you can see in many of the almost everywhere you could see the IoT kind of IoT kind of connectivity. So basically, IoT technology is an umbrella term that refers to the connecting the physical and digital component. I'll go a little bit quicker because I want to show you the practicals on it, right? So what are the different kinds of applications and what are its types? So five basic types of application of IoT are five basic type of applications of IoT are first one the consumer IoT, where the IoT is used for the consumer that we use for the consumers, like a home appliances, voice assistant. That means at the consumer, that means the client side. The consumer used to use the IoT for getting the different feature, light fixture. So we can turn off the light in the home, right? We can turn on, turn off the ACs. We can turn and turn off the washing machines, or we could have a IoT application, that means that's a home application of IoT for the home appliances, or voice assistant. We use the Google right Google microphone to give the instructions. Those instructions got executed over the IoT platform to command the television set. Please play this audio. Please play this video. So that comes under the consumer IoT. The second one is a commercial IoT, which is used in the bigger environment, in the or we can say which is used in the industries, right? So the application of IoT in the healthcare or the transport industry or the pacemakers, monitoring system, vehicle to vehicle communication. This comes under the commercial IoT. The internet industrial IoT, right? Which basically comes in the production environment, right? That means in the production environment, that means if a company want to is a manufacturing company, so there they can use the industrial IoT devices. So that include the digital control system, statistical evaluation, agriculture, or the industrial big data. Then fourth is the infrastructure IoT. So infrastructure IoT basically provides the infrastructure for the public social services. For example, is the smart cities. It is the infrastructure center sensors management system, or user-friendly apps are used for providing the different services. And finally, it can be used in the military as well, right? So like a surveillance robot or human variable biometric combat are the example of the military things, right? These are some applications which are executed onto the IoT platform. Consumer IoT, that is used for consumer, commercial IoT used in the commercial environment, industrial IoT in the production environment or the manufacturing section, and the infrastructure IoT, and finally we have the military thing. Then IoT pandemic, as you know, because of the pandemic, basically IoT has basically demand, right? You could see this. So IoT includes everything from sensor to the application, right? And most of the company use their most of the processes automated. So their automation IoT comes in the picture. So as you know, during this pandemic, it was basically not possible to move in and move out. So in those scenarios, basically this IoT has played a very important role where most of the I hope you might be knowing about the automated sanitization machines and all, right? Automated. So basically, what happens? The IoT has during the pandemic, the automation, most of the automation things has come to picture and get risen to the at a specific level, right? Regarding the workplace IoT beyond the manufacturing line. You could see this is what the Tata Communications IoT business search. So in September 2009, it was around 1,87,000. $604 and it has risen to 3,02,527. This is the data which got from the Gartner site. So that's basically explains that is tells you how IoT is important in the business. That it has a big surge in the past 6 months and it would go continuously. It would go continuously by on the at the peak, right? So now we understood what IoT is, what are the applications IoT, where we can use the internet and where you connect the things. Things are nothing but the devices. And through the internet or internet, we can connect those and we can basically perform the different activities of the task. Now, when we implement the IoT, there are certain types of risks. There are so many risks. We can't blindly go and implement. And so whenever we basically implement an production application, we need to consider risk associated with that. So there are certain risks associated with the IoT. Let us see one by one. So first one is the if you have a IoT solution, basically we used to use the Raspberry Pi or the Arduino, and we assign the username and the password to. So by mistake, if you assign the guessable or hard-coded password to the applications, so those passwords may get compromised, and the user could get access to all the devices which are connected to that particular controller, right? So this is what the first risk is, right? You do not basically assign the weak guessable or the hard-coded password because when you deploy the IoT on the cloud platform, it gets run over the public platform, right? Public internet, and when it is exposed over the public internet, so one may use it. One that means the attacker may easily guess the password, and once he get the password, through a controller, he may get access to entire infrastructure which you have deployed over the IoT. So very first type of risk associated with IoT is a weak guessable hard-coded password. Second type of risk is nothing but the insecure or unneeded network service, right? So what does it mean? So whenever you host an application to run the application over the internet or the intranet, and you could connect to those applications using the handheld devices or your smartphones or your personal laptop desktop. But whenever you access those websites, you do not try to connect it using the insecure or the unneeded network services. So if you do so, you may get your traffic may get what I can say injected, and can someone can steal the sensitive information from your application, right? So in insecure and unneeded network services which are installed on the devices may expose this data such as sensitive. We are basically aware of the mobile application, right? So whenever we install any application like a Google Chrome or the any browser, it may ask you to assign the permissions. That means to give the permission, camera permission, or give the permission to the voice, give the location permission, right? So many permissions we assign, and if we enable the keyword services, the keyboard services, right? So keypad services. If we give the permission to access the keypad, so whatever password will type through your mobile phone will be tracked by the hackers, right? Or attackers, and they can steal your data. Once they get the password, they can log in, they can change the password, and they can steal the data, or they can basically hijack the entire infrastructure which are hosted onto the IoT platform, right? So this is what the second flaw is, or second type of risk is, right? The third type of risk is basically is the ecosystem interface, right? So basically external interfaces that connect to the devices, right? So if you are connected to any external device, right? So that could if that device could get device could get compromised when you connect to the untrusted network, right? So if you use the untrusted network, so obviously your ecosystem interfaces also may get compromised, right? Fourth one, lack of secure update mechanism. So as you know, whenever we install the operating system, it continuously asks you to download the security updates, right? So those security updates are basically updated every week, and those needs to be applied because every security patch has the basically updation in the previous security policy, right? So you must if you have the lack of secure update mechanism, if you do not update it, right? If you do not make it your devices up to date, then it may get a vulnerable. It may expose the vulnerabilities. So lack of secure update mechanism, such as unencrypted data moving inwards output the devices. So if you update the devices, it won't allow you to basically put the packet filter. It basically put the packet filter, and that packet filter won't allow the third parties or the outsider to invert or import the unencrypted data flowing through the. So this is what the one of the limitation or one of the risks of the IoT is lack of secure update mechanism, such as unencrypted data moving from outward source towards the device or the poor security monitoring. So you must update the device, you must update the operating system which you have installed into the IoT devices periodically. Secure updates. Now, next one is the use of insecure and outdated components. So if you have a IoT device, the legacy devices, right? So legacy devices were not the updated ones. If those devices may have some weaknesses or some vulnerabilities, if those devices are having vulnerabilities, then it will expose. It may expose the vulnerabilities to outside, and then third part that if it is exposed, then through the weaker devices, the one can enter into your entire infrastructure, IoT infrastructure, and can make it the harm. This is what the another risk is of insecure and outdated components, such as the open source third-party component that where stand for the vulnerabilities. Next one, insufficient privacy protection. You must take care of the privacy. Privacy means what the communication must maintain the privacy. It should be communicate. The one can communicate with the application through the using the TLS protocol, transport level security protocols, or one may use the authentication, right? So multi-level authentication is one of the very important concept in the IoT cloud, right? And if you do not provide the privacy protection, then what will happen? If you lead and can make a harm to company. So failure to protect the privacy information is stored on the devices and connected ecosystem. So privacy is another risk which is there in the IoT, right? And this all the risk comes under the OWASP. OWASP is for O for open, W for web, A for application, C for security, P for project, right? So OWASP has defined this risk, right? And this risk has to be addressed during implementing the IoT project. Then next is the insecure data transfer. So there is the if you provide the lack of access control and encryption during the movement, then it may be an insecure, right? And lack of the device management, you must provide a device management at the centralized location where the in the production environment the administrator should have the administrator basically ask you to manage the devices. Do you want to give a control of your devices to the IoT admin portal? You must always give your control to the administrator so that he can continuously check your device and can basically update the device, can do the patch management, or right. So or he can manage your device in the production. Device management is another risk, right? Are there insecure default physical risk you can see one by one, right? First one was SML password. Second, you must provide the strong password to your IoT device. Second, do not use the insecure network services. Third one, do not expose your devices to the insecure. Fourth one, regularly update the devices. Fifth one, right? Do not use the legacy or the outdated components in your existing infrastructure. And next one, you must provide the good privacy or the sufficient privacy protection for the communication. And then you must provide the secure data transfer and the storage, right? So that means the encrypted storage comes as like encrypted block level storages, as well as the. So I'll show you in the Amazon services how to create such kind of devices, and then the lack of device management. You provide a device management option to the administrator so that he can continuously monitor your device and can basically address activities, as well as insecure default thing, and what are the IoT security pros and cons, right? these are what the least of the IoT security in the traditional IT environment, and IoT, that means the IT security in the traditional environment. That means how the security is managed in the traditional IT. And if you use the IoT, then what would be the benefits? What benefits you would get to provide the security? First one, in the traditional environment, we have the add-on security, while IoT has the built-in security, because the IoT application runs on the SHA MD5, right? So those application basically runs through the tunnel, so it has a built-in security. In traditional IoT security, the algorithms are little complex, but in IoT security, the algorithms are lightweighted. In IoT, in traditional IT security, the control is managed by the user. It's a manual thing, while in IoT security, it's a automated thing, right? There is a heterogeneity, large heterogeneity. Then many security guards are there, but in the IoT security, very few guards are there, but they are basically quite right. They are quite good, right? Better than the industry, right? So number is less, number is more, but although number is less, but the solution which are provided by the IoT security are always a good, better. So IT security is placed in the closed environment, is being placed in the open as well. And here you can see the layers, different layers of IoT security. So here we have the CoAP protocol and the HTTPS protocol. So in IoT, we use the CoAP protocol, which runs on the DLTS. Here we have the data transport layer system. Here we have the transport layer system. The protocols used by the CoAP are IP or the IPsec. Even HTTP also we use IP and IPsec, and the rest of the layers are same. So these are the layers used in the IoT security and the traditional IT. Because in traditional IT, we run the application over the HTTP protocol, while the IoT application we runs on the CoAP protocol. Right? We have the limited resources embedded. So what are the resources used in the IoT? Embedded devices are there, RTOS is there, then the traditional security won't run, right? So these are the limitation. First limitations are limited resources. Second is the no security limiters are there for the application. Then there are the only unique use cases available for the IoT, right? Right. I want to show you these things practically. Now, very important. What are the attacks till now happened over the IoT devices? What are the popular attacks, right? So very first attack was happened in 2010, which was the Stuxnet, right? So basically, Stuxnet was the worm attack, right? And it was basically happened in nuclear plant where the industrial IoT, right? And this worm attack was happened in the PLC, the nuclear plant, and basically this Stuxnet attack, 2.5 million devices got compromised because of this attack. Second one, Heartbleed attack. The Heartbleed attack was happened in 2014. It was a TLS, transport layer security exploit attack, because it has basically leaked the tunnel through which data got transmitted through the encrypted channel. So TLS exploit, the Heartbleed attack was happened due to the TLS exploit, and it has exposed the encrypted data which was flowing through the tunnel, and it was happened because of the buffer overflow in the tunnel. And because of this Heartbleed attack, 200k devices, right, were affected. Then Mirai attack, right, which was happened in 2016. It was happened because of the weaker password, right, and the attack was happened due to the password exploit, right, and because of password exploit, the system server, that is the server on which the IoT controllers were installed, got compromised, and they basically got the IP address of that particular server, and they started flooding the network using the DDoS, distributed denial of service. So because of flooding, no one were able to access the server, and because of this Mirai attack, 2.5 million devices got affected. And this is one of the most popular attack, which is a ransomware, right? Which is called WannaCry, right? So this attack was happened in May 2017, and this attack was basically what happens in the ransomware. Basically, basically when we try to access the website, say any one of the website may have some kind of script. So if that script gets executed, it starts encrypting your data, right? Data on, right? And WannaCry is a type of that only. So it starts encrypting it. It encrypt all the data, all the files, right? All the data, all the files, all the directories, all the applications which are there in a computer. and it just send you it just download one txt file in your computer and just shows you you just pay this xyz amount to me so that we can give you the decryption password. We could give you the decryption key, and using those decryption key you can encrypt you can decrypt your data, right? But they do not do so, right? They ask you the money. You all, once you pay that, they will not entertain, right? So many frauds had happened in the had happened in 2017 when WannaCry had come. Many of the banks got also exposed to this WannaCry virus, right? So WannaCry is a network worm, right? It's a worm exploiting the SMB, simple messaging, right? And that is a message broker architecture it has used. So network worm exploiting the SMB and encrypt the user data ransomware. So ransomware is nothing but the encrypting. And because of this WannaCry, 300K devices got infected, right? The Bluebird happened in 2017, which was a Bluetooth penetration attack, right? Somebody has started penetrating the Bluetooth of the other devices, and because of this Bluetooth penetration, 8.2 billion devices got affected. Then the crack attack happened in 2017, which was based on the Wi-Fi attack. So Wi-Fi WPA2 wireless privacy access to exploit attack, and it was happened because of the key access mechanism, right? And it has basically compromised the so many Wi-Fi devices. And then meltdown spectre, which has happened in 2018. It was basically happened. It was basically used for targeting the processors. So if you run in the IoT, basically we use the processing powers of the controllers, right? So whenever we use the processing power, this meltdown spectre used to basically target the processors and the memory access of the particular process, so that your process or the your executing job may get disturbed or not get executed, right? So there are the different types of attacks happened onto the IoT devices, right? Now, what are the solutions to this problem, right? If we have seen the different types of risks, as well as we have seen the different types of attacks. Now, what would be the solution for this problem, right? So, as you may say, there are generalized solutions, right? One of the first solution would be use the strong password, use the multi-factor authentication. You may say you can use the certificate-based transmission of data. Then you may use the TLS mechanism, transport layer TLS protocol for the transmission of the data. Or for the encryption, you can harden the security using the different multi-key algorithm, or asymmetric key encryption algorithms. Right? So many solutions are there. Let us see one by one. So IoT devices built-in security controls. So basically, we provide the multi-factor authentication. So multi-factor authentication stands for, instead of using only a password to access the services, you'd be asked to use the OTP as well. You would be asked to share your OTP. You would ask to share your thumbprint, right? So that is called as an MFA. So I'm going to show you MFA as well in the Amazon Web Services. How to enable the MFA, and how to log in using the MFA. So authentication is one of the very right, is that entry point to the application, IoT application, because whenever we basically want to manage the device, we basically first authenticate it by username and password. And once we successfully enter the username and password, we get entry to the application, and through the application we can manage the device. So authentication is the entry point. So at the entry point itself, we need to protect. And to harden the authentication, what we can do, we can provide the strong password, right? We may have, and we may provide a different password policies, like the password should have the lowercase letter, uppercase letter. It should contain at least one special character. So these kinds of password protection policies we can apply to the authentication. And along with the authentication, we can enable the MFA. MFA stands for multi-factor authentication. So along with the password, once you enter the password, it would ask you to enter the OTP, which is received, or which is been sent on your mobile. So once you successfully enter the OTP, you would be allowed to enter. Some of the websites may ask you the three-factor authentication, right? So one factor means only password. Two factor means what? Mobile plus mobile OTP plus your password. Three-factor authentication means what? First, it would ask you to enter the password. Once you type the password, second factor would be the OTP based authentication, and third factor would be, it would ask you the biometric, right? So you have to basically put your hand, that means you have to give the thumbprint and it matches the thumbprint. So this, that is called as a three factor: thumbprint plus OTP plus the password, right? So multi-factor authentication would be always better to use in the IoT, because we connect multiple. If you have a bigger environment in the industry also, if you see industry, people used to have the IoT based production application where they used to run the thousands of to thousands of devices. Once you compromise the application, all 2000 devices may get compromised, which may give you the huge financial loss or the huge that means huge loss, right? So authentication is one of the first security control, right? Second, secure boot, right? So IoT devices, in IoT devices, we most of the time used to have the Linux based operating system. So you must try to boot their system using the secure, right? Third one, you must update the operating system installed in the IoT controllers. Securely update, regularly update is always better to have it updated, right? So once you update it, right, it install the security patches which would make your devices more what I say, more commandable in this in the security in terms of security. Then try to install the embedded firewalls, right? Firewalls plays an important role when you flow the traffic ins and outs of your network, right? So if you put an embedded firewall there, you can write the access control policies, and in the access control policies you can write this is what the range through which only request can be sent, and this is what the, and rest all the networks would get basically would get denied. Right? So for example, suppose I have an organization in which I am using a class C IP address 192.168.1.x. So I can write a rule: the traffic, that means the inbound traffic. That inbound means what? When I'll access the IoT application, I would be a outsider, suppose. So if my IP address belongs to 192.168.1.x, then only I should be allowed to access the system, right? So inbound addresses and outbound addresses must be defined when you expose your IoT, when you expose your IoT things, Internet of Things, IoT applications over the internet. Because in the internet you may use the two networks, separate networks, private network and the public. Private is nothing but the intranet of your organization, and the public would be the internet. So secure embedded firewall comes into the picture when you have the both the that means you have to use the two networks, private plus the public. So in that scenario, you may install the firewalls, which may be the embedded firewalls, which could be either hardware based or the software based, and these firewalls would filter the traffic. Packet filtering would be there, as well as it would allow you to write the access control policy, like where you can define what IP address range should be allowed, what IP address range should be denied. Those kinds of rules, that kind of rule can implement. As well as it has the feature called as a NAT, network address translation, which can be used for converting your private to public, public to private IP addresses, right? So you can define how many devices would be the admin. That means how many devices could be used for accessing the application. Secure communication is one of the very important factor, where if you are running the IoT devices on the cloud, you must choose the appropriate CDN. CDN stands for content delivery network, right? You must select the appropriate CDN of the trusted provider, not anyone. So you may right now you can see there are so many cloud service providers from the China. They provide you very cheaper bandwidth, as well as give you the storage at very cheaper rate, right? So you don't go for them because they are not trusted. They are not trusted. Once you deploy your things onto their platform, they will start blackmailing you, right? So always go for the trusted provider, right? If the trusted provider is there, he will take care of providing you the secure communication, because when you opt the trusted provider service, he will provide you the SLA, service level agreement, and in that SLA he'll define what type of security measures he is taking, and how he is going to share the how he is going to provide the services in a secure way to your application. I'll go next. Data encryption is one of the very important factor, where data must be encrypted, which is flowing through the network from one channel to other channel. Secure firmware updates, or this security and the management. So these are the basically measures, right? These are the factors which are essential in the IoT devices when you want to secure the IoT network. Right? This is what the secure boot process. Second first, that means the first stage bootloader, which is basically create and crypto shared with the second boot stage loader, with the operating system, with the application. Then what are the properties of highly secure devices? Seven properties. First one, hardware should be root of the trust. You should have the defense in depth. You should have the small trusted computing base, dynamic compartment, And very important, you must have the certificate based authentication. Unless if you do not have a certificate based authentication, probably you would not be secure in that. So you must have the solution for the failure reporting as well. So if any failure occurs, it should immediately send you a notification about the particular failure, right? And let us start with our main topic, which is the cloud IoT and the cloud and IoT security. I just give you the glimpse about the cloud, give and the IoT we have already seen, and then I'll directly start with the demonstration, right? So till now, any question is there? Yes. Till now, any question is there related to the basics? This part you might have covered in the other sessions as well. So I just we have just the rehearsal of those topics. Any question is there related to these topics? Ma'am, am I audible or not?
Yes, sir, you are audible.
Yeah. Yeah, thank you so much, ma'am. So I'll quickly go through the IoT and cloud security, and followed by that, I'm going to show you the practical demonstration how to that is what are the cloud services provided by the Amazon Web Services and how to use them, right? So first, what is cloud computing, right? And why we use it? Why cloud is the buzzword? Why every organization wants to use the cloud? So as you know, cloud computing is nothing but the provision of the resource pool, right? So in a simple way, I can say the older definition of cloud computing was it's a dynamic delivery of IT resources as a service. It's a dynamic delivery. Dynamic means what? From anywhere at any time on any device. It's a dynamic delivery of IT resources as a service over the network, could be either internet or the intranet, right? So what is cloud computing? So they basically in cloud computing they have the huge resource pool. They have the resource pool. What is the resource pool, please? For example, suppose I want to run an application, and suppose my application requires 1 terabyte of RAM. Is it possible to insert 1 TB of RAM into the computer, physical computer? Not possible, right? You can't insert 1 TB of RAM. So what to do if I want to run a heavy weighted application, which is a scientific application and requires 1 terabyte of RAM? That capability is provided by the cloud computer, the cloud platform, right? So in the cloud, you get the unlimited capacity of resources, unlimited RAM, unlimited CPU size, unlimited storage space, whatever quantity you want to use, you just ask for the CSP, they'll deliver to you. At the background, they'll create a virtual machine with the operating system and they'll provide you the server through which you can execute such kind of applications, right? So cloud computing basically is, I can say, as per the Gartner as well as the industry definition. So cloud computing is a convenient delivery of IT resources as a service over the network, and which basically can be which can be easily provisioned and released with the minimal management effort. Right? Released with the minimal management. So you can, what is cloud? So you can basically log into cloud service provider, right, which is a public platform on which once you logged in, you can access the services, and they provide you the different pricing for different components, and it's a utility based model. So basically utility means what? You have to pay whatever you use. If you use the cloud services for 1 hour, just pay for 1 hour. If you use it for 5 hours, just pay for 5. So utility based model is there. So what happens in utility based? So suppose you want to run a server, Windows server, and on that Windows server, suppose you want to host, right? So traditionally, how we do that? So in traditional way, we basically install a server, right? Physical server, we procure a physical server. In physical server with the high-end infrastructure, high-end hardware would be there, right? Like a multiple CPUs, like a quad core CPU with the quad core or octa core CPU, or we may have the RAM size of 64 GB, 128 GB, right? So we basically purchase a high-end server first. In that high-end server, we install the operating system, right? And upon installing the operating system, we deploy the web server and we host the website, right? And upon hosting it, we basically connect that server over the public platform. And to expose it over the public platform, we basically purchase one static IP address, public IP address, and we assign that IP address to our server. And we assign the domain name as well. We assign the domain name as well. That is called as an in-house hosting of the website. What changes happen due to the cloud? So if this is the same procedure, if you want to do it in the cloud computing, you need not have to procure anything. Very important thing. Everything is readily available in the cloud. Everything starts from the hardware to the software to the operating system to the applications, right? All the things are readily available. So in the cloud computing, basically cloud service provider directly provides you a web server, right? Readily available web server. And you just what you have to do, you just have to assign the memory size and the CPU size to that server. And once you assign it, your web server would get ready, right? And on that web server, you can easily host the website, and you need not have to purchase the separate domain name or the separate IP address. It will be provided by the cloud service provider only, right? And it would be a bundled. And if you compare the pricing between the in-house hosting and the cloud hosting, so in-house hosting would be very expensive. The CapEx is very high because you have to spend lakhs of rupees for purchasing the server. You have to spend 10 to 20,000 for purchasing the operating system. Then you need to pay for the infrastructure cost. You need to pay for the administration cost, right? System administrator, network administration cost. There you need to basically procure and monitoring solution. You need to procure the public IP address to host it. So many things are there, and and once you deploy it in house, there is a capex as well as the opex as well. Capex is the capital expenditure for purchasing these things, and opex is the operational expenditure where you have to continuously, that means every year you have to pay the maintenance cost. So the cost would be very high in terms of that is in terms of the in-house server. Only benefit you will get is the security, because your own security is, your own administrator writes the security policies to protect the services hosted onto in-house server. But same thing if you want to implement into the cloud computing or the cloud platform, then we need not have to purchase anything. We need not have to set up anything. We need not have to do anything. Just have to go to the CSP's website. Their ready-made servers are available. You just select the appropriate server, select the appropriate hosting platform, and just deploy it and specify the hardware size, that is the RAM size, CPU size, bandwidth, your domain name, right? All those things you assign, and within a fraction of a second, 10 minutes, your server gets ready. 10 to 15 minutes, and you can easily host, and your customers can easily access your website through the domain provided by the website. So it's a very simple task in the cloud. And what about the costing? You said, as I said, there is very high cost in the in-house infrastructure, in-house hosting. What would be the cost in the public platform? So in the public platform, you just have to pay the operating system cost, right? Operating cost, system cost would be 10 rupees, 5 rupees to 10 rupees per hour, right? Plus you need to pay for the public IP address. That would be around 1 rupees or 1.5 rupees per hour, right? And then you need to pay the hardware resources. That is the number of CPUs you have used for the web server, and amount of memory you have used, and the storage used. And apart from that, there is no additional cost, and this cost would be a per hour. So they basically, Amazon Web Services is one of the most popular cloud service provider in the world who have grabbed the 70% of businesses in the world. And what are these Amazon Web Service providers? So they are very cheaper. So I want to show you free tier account where you get all the cloud services free of cost for an entire year. I'll demonstrate that part, right? So if you deploy the same thing over the Amazon platform, they provide you three options. Either you can go pay as you go, that is pay per hour, pay per minute, or pay per second plan. Or second, you may go for the subscription plan. Subscription means subscribe for 1 hour, subscribe for 1 month, subscribe for 3 months, subscribe for entire year, right? So if you are getting a virtual machine, if you are getting a bundled cost for, if you are getting bundled cost per hour for hosting the web server, as in 50 rupees per hour, if you host the same, if you basically opt the subscription plan for the same thing, it would give you the same plan in 20 rupees per hour or the 10 rupees per hour, right? Depends on how long you run these servers, how depend on how long you subscribe the services. So depends on the duration, the cost varies. The higher the duration, cost would be very low. Right? So that's why everyone likes to opt the cloud services, right? So let us go through the slides, but then I'll show you the demonstration. Right, it's 2:30. I have only 45 minutes left. So constant. So a cloud-enabled IoT means what? As you know, we have the constant of IoT devices. Right, we can limitedly use the resources. We can limitedly use the network services to host onto the internet. But what cloud computing provides you for the IoT? So cloud computing usually supports the IoT deployment. It provides a seamless communication. Seamless communication means what? End-to-end communication between different devices of IoT. and the cloud platform, or device to device, device to cloud, cloud to device. All the types of services are provided by the cloud itself. You did not have to do manual wire connection. You just have to drag and drop the arrows by connecting those arrows, and once you deploy those arrows, that means once you deploy the diagram into the simulated diagram into the green grass, IoT green grass, it would make the seamless communication for the data. So the effort is very, very, very low in the cloud computing, right? Because everything is a GUI based, right? So first one, the seamless communication provides you the good bandwidth for communicating the different devices. Second, unlimited resources. As I said, you get unlimited compute power. If you want to run a IoT application which requires suppose 10 GB of RAM, you can of the 10 GB of RAM, you can get the 10 GB of RAM from the Amazon server. I'll show you that also. So unlimited compute power, unlimited storage, unlimited network power you get through the cloud. Meaningful insights. So cloud has built-in analytics, right? So if you can basically plot the analytics of your application, that means what is the performance of your application, then what is the performance of your application or your devices, their analytics, their visualization can be depicted for getting the meaningful insights through the cloud. It also facilitated the faster application development because it used to communicate using the APIs, and most of the APIs used in the IoT as well as in the cloud are the REST API. Rest of the representation start transfer state, which are the open source. It also provides you virtual things and the virtual thing management as well as the access control panel. I'll show you this part, right? So we know the cloud computing. For the cloud computing is used for getting the unlimited resource power. We have the IoT, right, where we have the sensors, right, actuators. We have the controllers, right, where we deploy the things, and we can host these things over the cloud. But while hosting these things over the cloud, we need to take care of one parameter which is called as a security, which has a broader spectrum in terms of the cloud-based IoT. This is what the diagram where you could see how cloud has evolved. First, standalone computer used to use for deploying the things. Then web has come where we used to use the web server to run the application onto different computer, 2-tier application. Then cloud has come where the entire application comes into the picture, and the cloud plus IoT is nothing but entire architecture along with the IoT application. Here you can see the new challenge comes into the picture, which is the big data, right? So when you use the IoT, Internet of Things, it generates a huge amount of data, and there is a need for managing the data. So if you have the in-house application of IoT, and application is generating huge amount of data, so it becomes very difficult to store that, right? Every day, if your application size, if suppose today suppose your company has suppose today only 100 customers. Suppose those customers get rising from the 100 to suppose 1,000. So if 1,000 customers basically interact with your website, then they need additional bandwidth, they need additional storage, and it would generate additional storage also. That means storage it would require additional storage space also for storing their data. So you can't predict anything. So big data is basically a thing which basically looks into the big amount of data, which basically look into the four concerns of generated of the internet. So four concerns of the data are: first, speed of the data generation in IoT is very high. Then the volume of data generated in IoT generated by data generated by IoT devices is very high. Then velocity is very high. Volume is very high. It generates a variety of data, including images, audio, video, picture, JSON, VSON, PDF, compressed file, as well as it has a veracity. That is the data which is generated by the IoT devices, which is the uncertain format, right? And the cloud computing can take care of executing the things. But if we have the different, that means in the traditional way, basically we used to run the big data application separately and IoT separately, and you need to communicate between those using the network. But if you opt the cloud, computing cloud for that, this computing cloud will take care of deploying the big data plus the deploying the IoT together. And the single platform will be used for managing both the technologies, IoT as well as the big data, right? Big data is not just volume, it along with the volume is nothing but the size of data. Not just the size of data, it could it could have the huge velocity, it could have huge variety, right? The example of huge volume, velocity, and variety is the geo distribution of the IoT. That is a special data set where the different kinds of maps are generated and are stored into the IoT storage. And if you use the traditional storage, which are basically insufficient or not capable to store, process it, and analyze it. So we go for the big data where it can allows you to store huge amount of data, can process it, right? Can store it, analyze it, process it, and find the insight from that those kind of geo distribution maps, right? So technical aspect, data collected store continues to grow exponentially. It is increasingly everywhere in the many formats. Technical solutions, the traditional solutions are failing under with the failing for the new requirement. Finally, aggregation in the process. So these are the four limitations of the big data. First one is the volume, that is the size of data generated on internet is very high. You can't predict how much data per day can be generated, can get generated. For example, if you have, you can see the Facebook every day Facebook generates around 600 petabytes of data, PB of data, which may rise from 600 to 800 or 1000, right? We can't predict the volume or size volume of data being generated by the website. You can't generate the velocity of generation. Velocity means that today your application may generate 1 MB of data. Tomorrow it may generate 100 MB of data. Day after tomorrow it may generate 500 MB of data. We can't predict the velocity of data. And data is generated in various variety of format. It including volume. It including the structured data, unstructured or the semi-structured. Structured means the textual data. Unstructured means semi-structured means a graph, and unstructured means it may composed of various images, audio, video, JSON, BSON, PDF, compressed file, right? So this kind of data is being generated. So we need to look at the variety, we need to look at the volume, we need to look at the velocity, as well as we need to look at the veracity. These are the four important pillars, four basic challenges about the big data. And these challenges could be managed using the different big data framework like Apache Hadoop or Apache Spark or right? Apache Samza or the Kafka, right? And these things are readily available in the cloud platform. And as you know, IoT is also readily available. So we can make a connectivity between the IoT application and the big data in the cloud. So where cloud would be a backend which is used for providing the resources and providing the bandwidth for flowing the data. Big data would be used for storing the data, processing the data, analyzing the data. And IoT devices would be used for capturing the data. Right? This is what the interlink between the big data cloud and the IoT. I repeat, IoT basically is used for basically capturing the data from different sensors, right, and performing the actions onto that, right? So capturing and the processing are the applications of IoT. The big data is used for storing the data, analyzing the data, and finding the insights from the data. And if any threshold value gets up, then the big data would give the would basically generate an interrupt, and then that interrupt would get executed by the IoT device, and as per the interrupt, it will perform the action at the action in the IoT device itself, right? So, for example, I can tell you in a healthcare monitoring system where we have the wearable device, right? So, if you have a wearable device nowadays, most of the wearable devices are cloud enabled or the cloud based, right? So in the cloud-based cloud-based wearable devices, what happens? It continuously track your blood pressure, it continuously track your heart rate, and so many parameters, right? Oxygens and oxygen levels and all. So it continuously monitor, and then we have so that device is called as an IoT device, which is connected to the centralized controller at the cloud end, right? And that cloud end, that controller basically captures the data continuously and store the data into the big data processing engine. What that big data processing engine has, it continuously track and stores this data received by the IoT controllers. And what it does basically, it check the threshold value. If your blood pressure goes beyond the threshold value or goes below the come below the threshold value, then it generates an interrupt. That interrupt would be provided, which would be executed on the cloud platform. That cloud platform has a notification service called as an S. That notification service generates the messages and immediately transmit those messages to the nearest hospital or nearest hospitals, doctors, as well as the ambulance. And if the condition is critical, then immediately the ambulance is being called. You need not have to do anything. This is called as an automation example. So ambulance will take you to the hospital, and immediately at the moment when the ambulance got the notification, that the same moment the specialist doctor also gets the notification, and that doctor may quickly reach to the ICU or the ward wherever that patient will get admitted. So that is before reaching the patient to the hospital, your entire thing will be ready, right? Your doctors will be ready, your bed will be ready, everything will be ready, so that there is no wastage of time due for getting the treatment for the patient. So this is just a simple example where cloud, big data, and IoT comes into the picture. IoT for capturing data, big data for processing the threshold, and then a cloud platform for making the communication between the end user devices, sending the notification, and all the rest of the things. I'll show you that part right in some time. So I'll go little bit quickly because I want to show you these things practically, right? The ubiquitous connectivity is there pervasive, and this is what the cloud along with the big data, considering how to manage the big data on cloud, right? Combining cloud and the IoT. So cloud plus big data, cloud plus IoT, and their benefits and the challenges are given. Cloud cloud enabled IoT. Cloud enabled IoT provide you more intelligent application, flexibility of resources, energy saving, no on-site infrastructure, heterogeneity. What are the things I have explained? Scalability. This is what the one of the important feature is. Scalability. So what scalability does? Suppose you have 100 customers today, and suppose they suddenly rises from 100 to 1,000. So when your number of customer gets increased, you need to increase the bandwidth, you need to increase the CPU processing power, you need to increase the memory size of the virtual machine. So in the traditional environment, what happens? So as we are already aware about the university result, right? So the day when university is going to display the result online. Suppose university wants to display result at 12 o'clock. So at 12 o'clock, if you try to access the website, you will not get access. You'll see the page cannot display, because what happens if at the same time if they used to open the suppose 10,000 slots to the people, and suppose 1 million people used to try to access the same page, which makes a congestion and stop the entire website, right? Even we may have a we already know the example of IRCTC. So in earlier days, when the Tatkal time was between 10 to 11, we all tries to access the IRCTC server between 10 to 11, and it used to be it used to be basically it didn't work, right? Because of the that means that time the capacity of server was around 1 lakh people, right? And 10 lakh people used to try to access that server. That means it gets basically all the slot gets full, network slot gets full, and there's in congestion. That's why because that's why they have opted the cloud. In the cloud, the scalability is there. So nowadays, if you could see, the entire IRCTC has posted their applications onto the Amazon Web Services, where the scalability is being provided. Scalability stands for scaling up the configuration. Scaling up is not increasing the capacity of the hardware and decreasing the capacity. Scales up and scale down. So if number of user increases, it automatically without stopping the service, it automatically increase the RAM size, CPU size, then your bandwidth, everything it will automatically increase, right? And when there are no user, it automatically decrease those things, right? That is called as a scalability. So auto scaling is one of the very important feature or big feature there is there in the cloud computing. So it automatically scales up when there are more users. It automatically scales up the hardware configuration along with the bandwidth, and when there are no users, it automatically scales down it. Right? So that is called as a scalability. So because of scalability, nowadays your application won't get stop in between, right? It continuously will run onto the it will continuously run, right? Will not be stopped in between. This is what the diagram for IaaS PaaS SaaS. I hope you might be knowing the three basic services provided by the cloud: IaaS, SaaS, PaaS, and the services are provided through the virtual resources. And at the bottom we have the smart environment like a human and the go a little fast because I want to show you the demo. Right? These are the three basic layers which we have: IoT with the local distributed cloud. So nowadays people used to use the federated cloud, that is called as a hybrid cloud. So that federated means only any of the cloud. Suppose you have the two service providers. If one service provider gets failed, the other service provider will continuously provide you the service, right? And in the federated cloud, basically that is called federated. Second is hybrid cloud. Hybrid means what? Suppose you have an application which requires a high security, right? So the application which requires a high security, those applications you can run within the premises over the private cloud, and the application which requires performance, those application you run performance is a faster response. Those application you can run over the public cloud, and you can communicate between private and the public. So if any of the cloud gets failed, you can still provide the connectivity through the alternate cloud, right? This is what the Microsoft Azure is. This is what the IoT. This is what the IBM Watson is. And I'm going to show you the demonstration of Amazon Web Services now. Right? This is what the Amazon Web Services. Right? And this is the example of how to create the CloudWatch alarm. Right? I'll just close this. I'll ask you the question at the end. I have a 30 minutes to show the demonstration. Right? So I just covered the basic about the cloud-enabled IoT. And now I'm going to show you the demonstration. Right? Is my screen is visible? Yes. Is my screen visible to you?
Yes, sir. It's possible.
Yes. Chalo. So let us start with the IoT on AWS. So very first step, if you want to work onto the cloud, you must have an account onto the cloud service providers platform, right? So there are so many platforms available over the internet. The popular one are GCP, Google Cloud Platform, right? Right. So GCP stands for Google Cloud Platform. This is a platform provided by the Google, cloud.google.com, where you can run your hosted site. And basically Google Cloud. So basically you can see every cloud service provider will provide you the free credits. First time when you basically create your account, they will provide you the benefit, that means $300 free credits to use it, right? And then second, second biggest cloud service provider is Microsoft Azure, right? Microsoft Azure is a cloud by the Microsoft. You could see free account is there. In their free account, you could see they will provide a get started 12 months of free services. But if you compare this Microsoft, so recently they have started providing the free services for 12 months because they understood that this Amazon free tier is basically Amazon is providing the free services for 12 months. Could see many of the services they have free, but even Microsoft also started, but Microsoft services are more expensive than, because see the service cost for Amazon and Google is high, right? Higher than the Amazon Web Services, right? So 12 months popular services are free, plus you'll get the 13,300 credit, and always free 25 plus services you can continuously get these. If once you go at Microsoft Azure, little bit down. Here you can see create a personalized experience with AI. So basically, as I said, cloud becomes the platform for running all the kinds of application. I'm going to show you those technologies also. So 12 AI services which are free, right? So these are what the things you get. So Linux virtual machine. If you want to run the Linux server, so 750 hours per month you will get free, right? If you want to run the Windows virtual machine, Windows server, 750 hours per month you will get free. 750 hours per month, right? And if you count, so in the month, in a single month, so I'm opening the calculator here, right? In a single month, suppose we have on an average, suppose we have a 30 days multiplied by 24 hours, it comes to 720 hours. Comes to 7, so almost it's free. So if a month is of 31 days, then 31 days means what? You have to pay additional for 1 day. So it provides you 750 hours. Na? So it comes under 750. 750 is what? 31 days only. So sorry. So if you have a 31 days in a month multiplied by 24 hours in a day, comes to 744. So they provide you 750 hours of free per month. Then managed storage would be 64 GB of 2 SSDs you will get free. 750 hours of Linux virtual machine you will get free in the free account. You'll get the block level storage called as a blob, binary large object, 5 GB of blob free. For the file storage, like a simple storage service, object level service, 5 GB object level storage is free. 250 GB SQL database is free, right? So these things you get free for every month, right? Now next, they are providing these services free of cost for this many hours and these many minutes. Now, as compared to the Amazon, as compared to this, yes, madam, as compared to the Microsoft, we have the Amazon Web Services, right? So why Amazon? Amazon is one of the most leading cloud service provider in the world. So if you sum up the total revenue of Google plus total revenue of Microsoft Azure plus total revenue of Salesforce, Total revenue of Google plus total revenue of Microsoft Azure plus total revenue of Salesforce multiplied by 3 or 4 comes to an 1 year revenue of the Amazon Web Services. So you can imagine how much services they have, how big platform they have, right? How big platform they have. So as per the usability report of the in 2016. Amazon used to install 10,000 servers there, and it was capable of running 35. Right? So this much big infrastructure they have. It was initially a shopping company used to sell the book selling company, but they basically they landed up into the cloud world, and right now they are very big. If you want to use the Amazon Web Services, then how to do it? How to start? Now, if you want to start, you just go to the Amazon.com or simply go to the Google, Google.com, and they are just type AWS free tier. AWS FREE tier. So once you go to AWS free tier. Now one very important thing in the public cloud is whenever you create an instance, whenever you create any service, whenever you deploy something onto the cloud. Once your use is over, do not forget to shut down or stop the instance. Do not forget, right? If you forgot to stop the instance and if you keep it running at the background, your money will goes up, because when you create the free account, whichever account you create onto any of the cloud platform, it asks you to enter your debit card detail or the credit card detail, and unless and until you provide the credit card debit card detail, it won't allow you to create the account, right? So AWS free tier account, in the free tier account, what services you get? You will get 12 months of free. What services you get 12 months of free? 150 hours of you get 750 hours of elastic cloud compute. That is the compute where you can create the servers, operating system, hardware like a CPU, memory. You get the 5 GB of storage, object storage. You get a 750 hours of relational databases like a MySQL or PostgreSQL or Oracle SQL or the SQL server. These databases are free. So if you have an application, Python application, want to connect to any of the database, you may get the ready-made database over here. You can connect to your application. DynamoDB is a NoSQL solution. Then the SageMaker is very popular nowadays because it's a machine learning application, and which everyday scientists used to use for processing the machine learning huge amount of data, right? So this SageMaker has readily, that is the ready-made algorithms for classification or regression, right? Whatever thing you want to do, right? They have the ready-made application. Just need to provide the input data, and you just have to create the model. Once you create the model, they provide you the algorithms for running that, and these algorithms will run on the public platform on the live environment. Or the Amazon Lambda is the serverless computing where you use the instance of the server to run the application. Live itself is a platform as service where you can host the web server. Guard duty is nothing but the intelligent threat detection and the monitoring application. Threat detection monitoring application, simple notification for sending and receiving the message. Likewise, they have so many services, so many. CloudWatch for monitoring, API gateway to create the gateway, app stream. So you can't compare Amazon with any of the cloud, because they have right now they have 132 types of services. 132 types. Amazon Connect, EFS, Elastic EBS, Elastic Block Storage, Glacier, Game Lift. I want to show you these things practically. So very first step, if you want to create the free tier account, click on create free account. Then it will ask you to provide the username, your email ID, username, and the password. And once you assign the username, password, and email ID, then it will land up to the payment page. So in the payment page, you have to specify your debit card detail. That means your debit card number, name on the debit card, and then expiry of debit card, and finally CVV. And once you apply it, then they will send you the OTP on your mobile. And once you successfully enter the OTP from your mobile to that particular portal, your account gets created. You would get all these services free of cost. And what would be the setup cost? They will deduct only 2 rupees for creating the account. How much? Only 2 rupees. Right? So they will debit the 2 rupees from your account. So I'm selecting my role as an academic researcher interested in the AI machine learning and submit. So they will deduct only 2 rupees from your account, and then you create an account for you, right? And you can see thanks for creating the account. We are activating. So I specified the using my debit card and just now created the account. Let me sign into the console. So console is nothing but the entry point to the Amazon AWS cloud, right? So Amazon provides so many services. Let me show you the categories of services provided by Amazon. Just give me a moment. So very first thing, you have basically cloud is meant for providing compute, storage, and the network. Here we can create the compute. Compute stands for creating the virtual machine. That means what, as I said, suppose I want to run an application which requires 1 terabyte of RAM. How to 1 terabyte of RAM? Let me show you. I'll just create a virtual machine and will select the operating system. This is what my EC2 instance is. Right? So it will ask me which operating system on the virtual machine. So we'll show you the ranges of operating system like a Windows, Linux, or the Amazon Linux, sorry, or the Red Hat Linux. So we show you all, or Mac operating system, Mac OS Catalina, which operating system you want to run as a virtual. Although it will be a virtual machine that will appear as a physical machine. I want to run the Windows server. Please select here Windows Server date. If you want to run the some other, and here you could see one tag is there below the operating system. What is this? Free tier release. So free tier stands for you get the server free of cost. Need not have to pay for the operating system. I'm selecting the free tier for the operating system. It will ask you the instance type, how much bandwidth you want, how much CPU you want, how much memory you want, right? Each and everything would be shown over here, right? So family would be the 4 families are there, right? 6 families are there. Compute optimized, then the general instance, right? Then the memory optimized instances are there. There you get the more memory. CPU optimized are there, which will provide you the more CPU power, right? Or the storage optimized are there, which will provide you the huge storage space, right? So many options. This is what my free tier is. But let me show you how much capacity, how much bandwidth, how much memory it would deliver to you. Just see, this block is called as a memory, and this block is called as a CPU. As you know, in a physical computer, how many CPUs you can install? At most, we can install 8 CPUs, which is called as an octa-core. And in the physical computer, at most, we can install 128 GB of RAM. How much? 120. Now, just see these 2 columns, CPU and the memory. I'll just take it down, and here you could see it's going down again. Right, it's increasing. Here you could see this is a compute optimized instance which will provide you 96 number of CPU processors, 192 GB of RAM. How much internet speed you are getting? You are getting with this VM, you are getting 25 Gbps internet. 25 Gbps. Imagine. Would you imagine how much 25 Gbps kitna ho sakta hai first? Because in 1 Mbps internet connection, if you start downloading a file, it may take, if you start downloading a file of suppose 500 MB, it may take an hour. But in 25 Gbps, the moment you press enter, your 1 GB file would get downloaded in your computer. And this is what the bundled cost. This comes with the free tier account as well. Just go down. This column you can see it is increasing the RAM size, CPU size, compute optimized, storage optimized, right? Here you will get 64 CPUs with 488 GB of RAM, right? I'll go down. Right? Here you could see 96 number of CPUs but 768 GB of RAM. You are getting 7500, right? 7500 GB into 8 disks. Right, and you can go down, right? So like this, you can select the hardware configuration for VM. Let me go ahead. So you just have to select the operating system, then configure instance. You usually have to specify what would be your server name and all. Then add storage, you have to specify how much storage you want. Here you specify the name to the server. Security group, right? If you want to provide a secure access to VM, provide the security group, and finally review at the finish. Once you click on finish, your server get ready within a fraction of a second, and you could able to use it. I'll go back because I am more interested in showing you the IoT things. So here we have the compute instance, build app, virtual servers, IoT, right? And here I have the different services like a DevOps service, machine learning services, big data services, and then I'll just click on all services. Here you could see categories. The first category is the compute used for running the job, providing the compute power, CPU and the memory. This is for content where right Amazon bracket is there, right? Ready-made cons are provided for executing your job. This part is entire, but why Amazon is so much popular? Because they take care of security of their customers' data, and they provide so many modules, so many services for the security. Right? For the first one, the IA, which is identity and the access management, resource access manager. If you are providing your organization device accessing to the outside world, so in that moment you have to create the RAM, resource access manager, where you can specify a static IP. Only through that static IP only your organization's internal computer or server gets access to the outside world. Talking to the security service, a secret manager for protecting the passwords, different types of password, guard duty for providing the threat detection, right? Packet filtering. So it's a guard duty is an intelligent threat detection to protect the AWS account. So guard duty is a packet filtering engine. This is for inspector for the application security. Then the MASI is there for the cloud business critical contents. Single sign-on. If you have a multiple services on Amazon, and if you are using different username and password for different services. For compute you are using one username password. For storage you are using one username password. For containerization using one username password. So you can integrate all the username and password under a single portal with the SSO. A single username and password can be used for accessing the different services like a Google. So by using Google, you can access the YouTube services, you can access the Google Maps, you can access the Gmail, right? Likewise, you can create a SSO here. Certificate manager, where you can be a CA, certificate authority. You can create the certificate for your application. So the user who you have the authorized certificate only can access to your application. So here you can create the SSL or the TLS certificate. So, right, secure session layer and the transport layer security certificate, SSL TLS certificate. Key management, public private key management is there, right? Public private encryption keys. Then this is called as an hardware security module. If you have the hardware like a pen drive, to that means you want to program it to run the cloud services, so you can use the HSM module there, right? Directory services. Then this is for protecting against the DDoS and the malicious traffic. This is a software firewall to protect the IoT devices. This is called as an artifact to generate the SAS-70 or the SysTrust report, called as an compliance and the agreement report. Security hub, detective for detecting and analyzing the potential threats, audit manager. So these services are available for all the other services. In any service, we can configure these services, because this is an entire security model provided by the cloud, right? Next, compute for creating running VMs. This is for quantum computing. Why cloud is so much popular? It provides you the containers, it provides you the centralized storage, it provides you the databases, SQL, NoSQL. It provides you the big data analytics. What is big data analytics? It provides you the big data analytics in terms of Athena, Redshift, Elastic Map Reduce, right? Cloud search. So you can run all big data analytics application into it. Readily available Hadoop distributions are provided. Just have to provide the code, run the code onto these platforms, and just provide the either store data or the batch data or the stream data through the stream website, and through a Kinesis you can process it. Real-time streaming manager, you can see work with the real time. If you have a if you have a website like a share market website, where you want to write the stock market prediction. So those kinds of application can be run with the Kinesis. So Kinesis can track or capture the real-time data from the websites, and can use the prediction, can provide you different prediction algorithms to predict the future prices. So they already have the built-in solutions for this. And this kind of things can be used not only for share market, for any kind of website which has the real-time data, right? In the production farm, in the boiler also, suppose you want to perform any action. So in the boiler, suppose in the boiler system, suppose the temperature reaches to 200 degrees Celsius, and then suppose you want to stop the boiler. So in that case, what you will do, you will track the temperature using the real-time Kinesis, and you will have the IoT devices. In the IoT devices, you will continuously capture the data, and once it reaches to the threshold, so your cloud, that means your programming part, will be handled inside the Kinesis. So your Kinesis will generate a notification, will basically compare the data with the big data And once it reaches the threshold, it will instruct the IoT device to stop the boiler, right? This is for the satellite. Our matches runs on the through the satellite. The ground station is the satellite. It's the satellite kind of application. This is the Amazon managed blockchain. This is the RoboMaker where you have the software robots and you can do the programming in the RoboMaker. And then if your program is running fine, then you can implement it into the hardware, right? Actual hardware. This is for the game development. This part is for the IoT. We are concerning about this part, right? So let us go ahead. Let me show you this. This part is the machine learning part. You could see SageMaker, machine learning, deep learning, AI. Everything is provided. Readily available fraud detection algorithms are there. Forecasting mechanisms are there. Component is there. Then the augmented reality is there. SageMaker is there for the deploying machine learning models. Readily available algorithms and models are there in the SageMaker. Then this is called as an Lex for the voice and text chatbots. So ready-made chatbots is there. So you just have to type your question and your ideal answers. Based on that, you could integrate the ready-made Lex chatbot into your like a Alex only, right? Readily available chatbots into your application. Personalized poly for the lifelike speech or the natural language processing NLP and all. Poly is used for that. This is called recognition. So many things are there. Deep place for deep learning, deep racer, panorama, monitor. So many things are there for. So it covers all the types of domains, all the emerging technologies, machine learning, deep learning, IoT, robotics, blockchain, everything it covers, right? Even we watch the matches. So we need when your live telecasts happen, it happens. Your Hotstar uses Amazon services to host the website, host the or stream the videos, and to process the video, these media services are used. You can see this is what the Kinesis video stream. It is capture, process, and store the video stream, right? So real time. Earlier used to earlier when a live match used to be broadcasted, it used to be delayed of some minutes. So nowadays in Hotstar you can see the live streaming. Live means sort of there is a without a zero lag. You can see it. So it's because of the Kinesis only. It real time captures it. It real time captures the streams and then deliver at the user end using the Hotstar as the CDN at the backend. So it creates a CDN, content delivery network, between your device and the live telecasting device. Now let us go to the IoT thing. This we are concerning about this, right? So what are the IoT for the cloud? So Amazon has a huge support for the IoT devices. So first is the IoT core. What IoT core is? So IoT core allows you to connect your local devices to the cloud, right? If you already have the IoT infrastructure, so you can connect your IoT devices directly to the AWS IoT. So AWS IoT is a managed cloud platform that let connected devices, car, light, bulb, sensor, grid more easily and securely. You want to suppose you want to do the home automation and want to turn on and off your light, right? Your light at home, and suppose you are at the remote location, you are in Delhi and want to turn on and off from Delhi to, suppose your house is there in the Mumbai. So you could connect your devices to the internet, and through AWS IoT you can manage it, right? You can see these are the different segments. Monitor is used for monitoring the connection, monitoring the IoT devices. So right now we are not monitoring anything, right? Now we have not created the publish the messages. Onboard, if I'll go to onboard, right? So these are the fleet provisioning templates. So I can create the template for my application. So when I create the template first, as I said, cloud is basically provide you, Amazon Web Service basically provides you much more, that means provides you a hardened security for the IoT. So we will not compromise any device in terms of security. It provides you hardened security. So here I can type this template name, description. I can create the role. So very first step is when I want to connect my device, I have to create a template in which I have to define who are going to access my devices, right? Who are going to access my devices? What would be the access policies? How I'm going to give the access, right? And after that, I can specify the different algorithms of protecting it. So when I'll go to manage here, manage me, I'll go to the things. Things are nothing but my devices. Register a thing is nothing but registering my device. A thing is a representation of device in the cloud. So if I have a camera in my home, so I can register my camera. So create a single thing. I'll type the name of the thing, suppose camera, right? Then apply a type to thing. So I can select I can create a type, what using. I can search it if I do not have it, and I can create an attribute key for that particular, right? Then next, once you specify the type of thing, Then this is what the section where you can add group of people who can access. So you create a group here, type the name of the group, add the members into the group, they'll get access to it, provide the attribute key and the value. So this is based on the key value pair, and then click on next. Once you click on next, it will ask you to add a certificate. So this is what the beauty of Amazon Web Services, which provides you access to any of the IoT device by means of having the trusted certificate. So here you first, as a certificate provider, you will create the certificate. So I am creating a certificate. Once I'll create the certificate, it is showing a device gateway endpoint is not defined. So first I have to go to the network, have to define the gateway, that means the IP address through which the certificate gets validated. And then here I can create the certificate, and along with the certificate, it would generate the private and public keys as well, right? If a user wants to connect to my device, first he has to have the valid certificate, and after having the certificate, he'll get access to my website. But while accessing the website, it will ask the public key, it will ask the private key for that user, right? So it basically encrypt the entire site using public key and will ask you the private key to decrypt the services, right? If you do not want to use the certificate based authentication, you could so this is what certificate plus key, right? Certificate plus key based validation. If you do not want to use, if you want to use only certificate signing request based authentication, you can use this using a single private key, or you can use your online certificates, right, using a CA certificate, or you can skip it. So this is what the entire security things they provide you: billion of things, billion of group, whatever jobs you are running into the AWS, what are different types of tunnels you have created, right? So it basically provides you the it provides you a huge platform for managing and deploying thousands of lakhs of devices, right? Greengrass is nothing but the simulated environment where you can simulate the Greengrass. So let me go to the Amazon core here. Sorry, only 2 minutes are remaining. So I'll go to the services tab. Just give me 5 minutes, ma'am. I'll just take them through these services. So here I have the IoT core. Free RTOS is the RTOS real-time operating system on which you can perform the RTOS you can execute the RTOS application. IoT one click is the Lambda function, which basically uses the serverless computing devices. IoT analytics for analyzing, that means the collecting, processing, storing, analyzing, and visualizing the devices. That means how the devices are functioning, whether they are performing good, whether they are performing bad, whether they are having any problem. So it analyzes the device performance and will depict into the graphs, right? Then the device defender is the security solution. Basically, it's a defender where it continuously monitor or track the traffic between the devices. Device management, right? So securely manage the fleet, small one device to the broad millions of devices. So device management means whatever devices you have, right, physically. Those physical devices you can manage by clicking on to by using the single option. All the devices gets connected into it, and through a software Amazon platform only you can manage all the millions of billions of devices. This is for the event. As I said, triggered alert. I have already explained triggered alert. What triggered alert is. So trigger alert means what? Suppose as I said, if blood pressure basically reaches to the threshold level, it triggers the alert. Triggers means what? It sends the SNS to the simple notification message to the hospital as well as the doctors, and as per that they can basically act upon it. Greengrass is used for the deploying and running the code. This is the simulator on which you can run your different kinds of IoT code. This is for deploying the IoT industrial applications, and the graph for building the graphs. Any doubts are there? So this is what the IoT on the Amazon cloud platform. So I basically suggest you to create the account onto AWS free tier account and try these things, and do not shut down the services. So whatever services you create, just remember and just delete those services upon your usage, so that you will not get any. If you want to set any bill, you can go here. Here we have the billing section. Here we can type here a BILLING. You can set up the bill. You can simply go to the bill section. Click on the billing section. I'm just setting the threshold for the bill. That means my bill should not go beyond 60 rupees. That is 60 or 80 rupees, $1. So once I'll go to the billing management console, you can define how much bill you can bear. Right? And after once it reaches to the $1, it will automatically shut down all your services. Here it will show you month and day by spend services. Right now my usage is 0 INR. Right. If I want to set the budget, I can set the budget. Right. And in the budget, I'm going to specify my bill should not go beyond $1. Right. So create and manage budget. I'll click on it. Create budget, and so whenever you create account, the very first step is set the budget, and then later on you start using the platform. So I'm setting the cost. I'm specifying here monthly budget, budget, right? And it would be a recurring or expiring budget. Recurring would be fine, fixed, and fixed budget. It should not budgeted amount would be $1, right? $1. It would not go beyond $1. Then here I am specifying unlimited cost. So I want related to the credit and all, right? Refund credit should not go beyond $1. So configure the threshold. I'll go ahead, and when I want to stop the service, right? If my price goes 80%, 80% of 80 rupees is 80% of 80 rupees is 64. Once my cost reaches to 65 rupees, it will automatically stop my services or will send me the notification. So I'm typing my email ID here. So it will send me my email ID. I'll get the SNS also, simple notification on my mobile number. So I have to subscribe it. So I have subscribed to my mail, and I will confirm budget. So this will ensure me that my blended amount, budget amount is $1. My bill will never go beyond $1. At most, it will reach to 60 rupees, 65 rupees. And once it will reach to 65 rupees, I can quickly come here and can stop my services. Understood or not? So any doubts are there? Yes. I'm just. Yes, ma'am. Ma'am, your voice is not clear.
Hello.
Yes, ma'am.
Hello.
Yes, ma'am. Yes.
Yeah. Yeah. You have two questions. Can I take that?
Yes, ma'am. Yes, ma'am. You can take the questions, ma'am.
Yes. Our first question is like, is the fog more suitable for IoT device than cloud?
Yeah,
If
yeah.
yes, then how?
So I can read
Yes,
from the
then how?
chat section. Yeah, is the fog concept more suitable for IoT devices than fog? So I think fog is not that much suitable. Cloud is much more suitable to the IoT. So why cloud is suitable? Because in the fog you may get the limited services. The scalability is the basically big concern, major concern. So if you compare the scalability between the fog and the cloud, obviously you get more scalability in the cloud. As well as in the cloud, apart from the that means if you see the spectrum of the fog compared to the cloud, the spectrum of fog is little bit broader. That means spectrum of cloud is broader than, right? So in the cloud you get many more services which can be integrated along with which can be integrated with the IoT application. So if you just want to run deploy the IoT devices and want to run the smaller kind of application, smaller scale of application, then the fog would be better. But if you want to run it in the production environment and want to run the different services along with the IoT, like want to connect to the big data application, want to run the machine learning application over the IoT data, want to run the suppose deep learning applications over the cloud, over the IoT data. So in that case, the cloud would be a better solution than the fog. Yes, ma'am. Can I take the second question?
Yes, sir.
May I
Yes,
take
sir.
the
Yes,
second?
sir. We
Yes,
can take.
yes, ma'am. The second question. Yeah, second question is how the big data related to the IoT devices handle and secure, right? How the big data related to the IoT devices. As you know, the IoT devices basically runs over the internet, right? And the IoT applications are nothing but the websites. IoT applications are nothing but the websites which continuously interact with the IoT devices, right? So IoT devices are basically used for capturing the data, right? So if you have a bigger setup, if you have a production application running run by the organization, so in the production environment, like I have already shown the example of that IBM wala. So in the production environment, a huge amount of data is being collected by the IoT devices. So it's very difficult to manage such kind of data, right? So we store that data into the big data. That means the big tables or the, I can say, DynamoDB of the Amazon Web Services. So such a big data we store into the data storage, and that big data we process using the different big data analytics algorithms, using the EMR kind of application provided by the Amazon Web Services. So question is how the big data related to the IoT devices. So big data is related in terms of, because the IoT devices generates a huge amount of data. If we have the commercial application, suppose that application is basically used by, suppose, hundreds of thousands of customers. So every customer generates the data, right? And to store such data, right, the traditional servers are incapable. So we basically offer the big data solutions for solving that, so that we storing the data, processing the data, analyzing the data, and finding the insights from that. And the second question is it secure? Yes, it is secure, right? Because big data, if you see the IoT and big data deployed on the cloud, right? Both would be considered as an application. And I basically just demonstrated the spectrum of Amazon Web Services security spectrum, where these are the things which are commonly available for IoT applications as well as the big data application. Like IAM, identity and access management, where you can define the roles of user, to which user you want to give the admin access, to which user you want to give the limited access, resource access to manage your devices, or resource access. Cognito is used for basically managing the federated identities. Secret manager for the key access or key management. Guard duty is there for the threat detection. So threat detection means that if any threat comes, so it will automatically scans. So these are the common types of security applications applicable to IoT and the big data applications, right? So if you host big data and IoT both on the cloud, so your IoT devices gets connected to the cloud platform, and the cloud would be a mediator between the IoT and the big data mediator. So it is always a secure to have the cloud enabled IoT and the cloud enabled big. Yes, so questions are there apart from these?
No, sir. We have two questions only. Hello.
Yes, ma'am. Yes, ma'am.
Yes, sir. We have only two questions, and you have already answered those questions.
Yes, ma'am. Yes,
Uh,
ma'am. Yeah. So thank you so much, ma'am. Thank you so much
yeah,
all the
yeah.
participants taking time and attending my session. Right. I'd like to say thanks to the organizing team of this STDP Faculty Development Program, who have basically given me opportunity to talk in front of you on the topic cloud enabled big data. And I'll be sharing my details over here. If you want any help or related to the cloud big
Sure,
data analytics, or
sure.
I can share my email ID over here, on through which you can reach out to me.
Thank you, sir. We are glad to have a wonderful statement from your end. On behalf of Star Tech Engineering College, we have a small token of appreciation here for your please accept this token of
Yes, ma'am. Thank you so much.
appreciation.
Yes,
Thank you,
ma'am.
sir.
Thank you so much.
Participants, the feedback from attendance link is already there in the chat box. Please refer that. Thank you so much, all of you. Our next session is at 3:30.